Now, example, determine the oxidation number for the elements is in the following. Okay, for the F2 it's 0 as we mentioned in the rule number 1. BaO, okay, so the total charge of this one, if there is no charge on any formula, so it's equal to 0, okay, because it's neutral. Okay, so for the BaO, so we want to calculate the oxidation number of Ba, barium, okay, and we have to have the oxidation number of oxygen, which is -2. So how many atoms right here? It's 1. So we say 1, okay, times the oxidation number of oxygen, which is -2, okay, okay, plus Ba, which is like missing, equals the total charge is 0, and you get the Ba. For the PO4 -3, the -3 is the total charge, which must be like right here after the equal sign, okay, it's right there. So P is missing, okay, plus for the oxygen it's -2 times 4 equals -3, and you get the phosphorus. The third one is Mg. So this, like in one of the rules, we say like the Mg, the total charge of it would be the same as the charge of an element, so which is +2. Okay, the KCl. So for this one, it's like elements. For the K is +1. For the Cl is -1. Why is KCl? We did not like get it as the same as the previous one. So I want you to answer this one. This is like a homework. Homework. Okay, the KCl. Why did not we use the the rules, the same rules as the above molecules? Answer and send me the answer. For the SO2, S is missing. For the oxygen, 2 times 2, it's neutral, it's 0. Okay, this is all about it. So we have some examples here, so read them, do at home, practice it in order to get to know like how to do or to find out the oxidation number of any elements easily. So now let's move to the redox reaction. So we have, like, when we say a redox reaction, we are referring the reduction, we are talking about the reduction and the oxidation at the same time. So redox reaction means that it's a process that there is like an oxidation and reduction processes take place. So let's talk about the oxidation. It's a chemical change that is accompanied by a loss of electrons. So with the oxidation, there's an electron or electrons are lost, okay, from an atom or a group of atoms. So the process leads to an increase in the oxidation number. So with oxidation, losing electrons, oxidation number increase. So we have an example, sodium, like loss in electrons, the oxidation number increased. For the reduction is the opposite, so which means that we are going to gain electrons and the oxidation number decreased. It's the reverse or the opposite. Okay. For this one, each sodium atoms lost 1 electrons, as we mentioned. The oxidation number increased, and for the chlorine, they like gained 2 electrons, and the oxidation number decreased. We have some important rules right here. You guys gonna like go through them. The element that is oxidation number is increased is the same elements that the undergo a loss of electrons. So let's say that if we have a redox reaction, there is an oxidation and reduction processes are taking place. Okay, when we do a redox reaction for the oxidation, let's say that 1 electron is lost. In the other side, 1 electron is gained. So when we lose 1 electron in the oxidation process, we are going to gain 1 electron in the reduction process only, because one of them lost and the other gained the electron. This is all about. The number 2, the element that is its oxidation number decreases, it's the one that was reduced. So oxidation, reduction, one accompanies the other one. is the element that gains electrons, so oxidation agent. So we have something called oxidation or oxidative or oxidizing agent. It's the cathode ball, and for the reduction or reduced agent, which is the anode ball. So we have cathode and anode ball. Okay. Now let's move to the other one. The total number of the electron lost equals the total number of the electron gained. To obtain the general equation of the reaction, we need to sum or do a summation of the oxidation and reduction at the same time. So let's take this example and see how to get like the general equation of the redox reaction. So we have sodium and chlorine. For the sodium, so sodium lost 1 electron. Okay, for the chlorine it gained 2 electrons. So how to balance that? Let's see. This is the reaction, and the it's like its background is in a yellow color, this one. Okay, so since the chlorine gained 2 electrons, so the sodium must like lose 2 electrons in order to give them to the chlorine. So what are we going to do here is to multiply the first equation by 2, okay, in order to produce 2 electrons, and those electrons would be gained by the chlorine in order to cancel them out eventually. So they will be cancelled out, 2 electrons, and get 2Na plus Cl2 gives us 2Na plus 2Cl. Okay, so this is the last example for today's lecture. Determine the atoms that undergo reduction and oxidation, and then write down the half reaction of the oxidation and reduction. So first of all, we have this equation, okay, and we will talk about it. So what it requires from us to do here is to do the half oxidized reaction and half reduced reaction. So for this one, it's reduced, okay. The other one is oxidized. For the first one, so for the iodine, okay. So what are you going to do here is that to do a comparison between the left side and the right side. For the left side, you have Cl2. What happens to the Cl2? Is it was it lost or gained electrons? So for the chlorine, from the first equation, don't look at the solution. For the equation, as long as the chlorine turns into like a negative charge, okay, and it will as long as it was like an atom neutral, and then it turns into like a molecule that has a negative charge, okay, or a charge, that means there is like a reduction process takes place. So this is the reduction for the chlorine, and for the iodine is oxidizing process. The half oxidizing reaction means that you write down it's like 2I minus, which is this one, okay, arrow gives us what? 2 electrons and I2. For the Cl2, it gained electrons, 2 electrons, which means that it turned into 2Cl. So the 2Cl is the same as this one, okay, here, okay. And for the I2, it must be like in the product side, okay. So you do a comparison between what you have done and the general equation. And for the chlorine, so the chlorine here and the iodine must be the same as in the first equation, in the given equation, okay. And you cancel the 2 electrons here and 2 electrons here to end up with the equation on the top, okay. So what the question wants us to do is to just like separate them and indicate which one is the oxidation process and which one is the reduction process. The second one is the same as the previous one, except that the example is different. So Mg plus F2 gives us Mg plus 2 plus F. So what happened here? So we have Mg, okay, Mg plus 2. Okay, so it lost or gained. So it's oxidizing or reduction. As long as it gained and it lost electrons, so it's oxidizing. For the Mg, it's oxidizing agent or oxidizing process, and for the Fe, it's reduced or reduction process. Okay, and you do the same, cancel out the electrons, and that's it. Thank you, and I'll see you on the next lecture.